As we work with absolute value, we want to make sure we follow the same steps and information with these types of problems as we now get into inequalities with absolute value. So our objective is still I can solve and graph inequalities, but we're going to use absolute value and we're going to combine the ideas from both of them together. So first of all, let's talk about a couple basics just to understand what's happening with these absolute values. The absolute value of a number greater than 2, think about what numbers would work for that. 3 works, 10 works, 11.5 works, and also negative 2.7, negative 10, negative 12, those all work. So it's all the numbers that are greater than 2 and also, or the numbers that are less than negative 2. So any number in between 2, or actually at 2 and negative 2, between 2 and negative 2, or on those two, they don't work. Like if you put in 0, not true. But every number outside of it, so this says it's going to send it outside of those two numbers. It's really saying what we want the distance away from 0 to be greater than 2 units. So it starts it at 2, not including it, but then goes outside because it sends it far away for having distance being greater. That means that we're going to have x here, x is less than negative 2, or since it's joining those two together, that's the union, x is greater than 2. So one of the things I want you to recognize is when you have an absolute value with a greater than, absolute value on this side with the variable, that's going to be an or problem. Now let's try this one. Absolute value of x is less than 5. What numbers are when you take their absolute value are less than 5? Again, 0 works, 1.2 works, negative 1.7 works. In essence, it's every number from 5 down to negative 5 and every number in between. So now we've got between notation where this would result in x is less than 5 and x is greater than negative 5. We can write that as a between, but remember that's an and statement. That's the intersection of those two. So whenever you have absolute value where it's going to be less than, we're going to use an and the distance here is going to be in between or go between the two outer limit two numbers. Well, let's try this one. We're going to throw a little complication inside the absolute value. Think about what numbers would work for this. If we want this to be less than 4, if you put in, for instance, 8 minus 6 is the absolute value of 2 is less than 4. Or if you put in 3 minus 6 is negative 3, take its absolute value, that's less than 4. What we do is think about when this would equal 4. Well, if we put 2 minus 6, that would be the negative 4, absolute value of it would be 4. So at 2, we've got a limit to what we're working with. And then also if I put in 10, that would make the inside part equal 4. So 10 minus 6 is 4, absolute value is 4. So out here at 10 is the other spot. Now it's going to be every number in between. We named all those other numbers. The infinite number of numbers in between them, including the decimals in between, are going to be the values that work for that. And so this solution would be x is between 10 and 2. X is greater than 2 and x is less than 10, the between notation. Another way to think about this is saying that the distance from 6 to the outer limit here has to be 4 units, and the distance this way is going to be 4 units, both in the positive direction and the negative direction. 6 is right in the middle. What would we put in for x to make this equal 0? It'd be 6. That's the middle of the graph. And then 4 units on both sides. We want it to be less than it, so it goes in between the two numbers. All right, let's try some problems. So we're gonna, whenever we have absolute value greater than, where the absolute value is on the left, with variables, it's gonna be an or. When it's gonna be a less than, it's gonna be an and. Let's try this problem. So first step, when we do absolute value, remember the thing we want to do is get the absolute value by itself. So we're going to divide both sides by 3. Dividing by a positive does not reverse my inequality. Now I'm going to take and set up two cases like we do with absolute value, but the two cases are going to have, because it's a greater than or equal to, but a greater than part, we're going to put an or between the two cases. First case, you're going to just drop the absolute values. You're going to have x minus 5 is greater than or equal to 6. The second case, we're going to take its opposite. Just like all of these, it's either the number itself or its opposite. So we're going to have the opposite of that. And when we do that, we now solve each of our two cases with the or, meaning we're going to take the union of the answers. Add 5 to both sides, get x is greater than or equal to 11. Or, and here I'm going to distribute through the negative, so I'm going to get an opposite of x plus 5 greater than or equal to 6. Now I'm going to multiply both sides, I'm going to solve it by subtracting 5 first. So if I subtract 5, I get a 1, and then I multiply by negative 1, and remember when you multiply by a negative, that reverses your inequality. So x is going to be less than or equal to negative 1 there. This is with an or, so my final solution would be x is greater than or equal to 11, or x is less than or equal to negative 1. Now we're going to check that. Here's my graph. Let's do the graph real quick. Negative 1, solid dot on it going in this direction. Over here we've got 11, solid dot on it going in this direction. To check these, what you should do with absolute values is you've got three regions. You've got to the left of negative 1, you've got in between negative 1 and 11, and you've got to the right of 11. All the numbers in between negative 1 and 11 shouldn't work. Now there's an infinite number of them, so you don't want to check them all. But if you tried one of these, for instance, if we put in 0, 0 minus 5 is negative 5, absolute value is 5. 5 times 3 is 15. That is not greater than or equal to 18. So this region should not be graphed, which we haven't done. Let's check a number to the left of negative 1. Pick like negative 5. Negative 5 minus 5 is negative 10. Absolute value of negative 10 is 10. 10 times 3 is 30. That is greater than or equal to 18. So that region works out. Now check the region over here. And again, a number greater than 11, you could pick 11. You could pick a number larger than 11. Let's pick, for instance, 12, just to the right of it. Pick any number over on that region. 12 minus 5 is equal to 7. Absolute value of 7 is 7 times 3 is 21. 21 is greater than or equal to 18. So we've checked it out, it works. Okay, so I'll put a little check next to this to show that I checked it. Now let's try this problem. First step, we're going to subtract 10 from both sides. So you get negative 2 times the absolute value of 2x minus 4. It's going to be greater than, when I subtract 10, I get negative 24. Now I'm going to divide both sides by negative 2. Dividing by a negative, remember, is going to reverse my inequality. So I'm going to get a less than. Dividing negative 24 by negative 2 gives me a 12. I'm going to set up, now that I've got my absolute value by itself, I'm going to set up two cases. 2x minus 4 is less than 12. Just drop the absolute value in the first case. Since it's a less than, I'm going to use the word and. So I put an and there. We're either a less than or equal to. And now I'm going to take the opposite of what is inside the absolute value, because absolute value inside of there could be a negative. We'll take its opposite then, is less than 12. Now let's solve each of these. Add 12 to both sides. So you get 16. Divide by 2, you get x is less than 8 for this part. Over here, we get an opposite of 2x plus 4 is less than 12. At this point, I want to subtract 4 from both sides, so we get negative 2x is less than 8. And now when I divide by negative 2, I've got to reverse my inequality, so I get x is greater than negative 4. So my answer here is going to be that x is between 8 and negative 4, because it's an and problem. Okay, and if I look at the graph of this solution, I get x is, I've got negative 4 here, and I've got 8 here. I'm going to have open dots on each of them. Okay, I'm going to just test my region between the two. Good number to test is 0, just zeros between the two of them. Check it out in the original. 2 times 0 is equal to 0, minus 4 is negative 4. Absolute value of negative 4 is 4, positive 4. 4 times 2 is 8. 10 minus 8 is going to be 2. 2 is greater than negative 14. So it works. All the numbers between these two will work, and so I have my solution of negative 4 is less than x, which is less than 8, my between notation. Now here, I put this one in red just to kind of raise your attention to a certain problem you could have and why the checks are important. If I subtract 5 from both sides, you get absolute value of x plus 2 is less than negative 1. Now, notice an absolute value can't be less than a negative if you have that. So because of that, there's not going to be a solution to this one. If you were to solve it and check the regions of your solution after doing the two cases, they would not work. They would not work in the original. So be wary of this. If you ever get absolute value less than a negative, the answer is the empty set or an empty graph. You can't have a solution to it. Now notice here I had a greater than a negative here, and that was okay. You could have greater than a negative, and actually that might end up being all real numbers. But when we worked out the problem, notice we ended up when we had the less than a positive. That's why this one had a solution and this one doesn't. So in solving absolute value problems, you got to make sure you think of it in terms of setting up your two cases like you do with absolute value, putting an or an and between them depending on which direction the inequality is going, and then solving your two cases following the rules for inequalities, and then making sure you know how to graph the answer as well.